I'm David Schwartz. I'm the Chief Cryptographer at Ripple. Presentation is on enabling the Internet of Value, by which we mean being able to move value as easily as we move information. So what is this blockchain thing that we're all so excited about? Well, it's a new technology that presented itself as Bitcoin. And I think we see an analogy with the first developments of other technologies, where there was just some product that embodied that technology. But as the technology matured, we got different designs aimed at different use cases. We have, in the analogy, we have a vehicle for moving heavy objects. We have a vehicle that's more of like a sports car, and so on. So the design focused on the use case rather than just one design that fits every use case. Right now, we have something like 1,500 blockchain-based tokens, and they're fighting over what use cases they're focused on, whether it's payments, trade finance, whatever use case. And we looked at a number of use cases for blockchains, including things like securities trading, lending, smart contracts, insurance, and a long list of them. And one of the things that we discovered is that all of those use cases come back to payments. If you're borrowing money, someone's going to pay you that money after you borrowed it. If it's trade finance, there's going to be a movement of money. If there's a smart contract, very often that smart contract is controlling the movement of money. So in all of those cases, there's a value transfer. Ripple has become focused on that value transfer that we need for those other use cases. We've assembled a team of over 220 full-time employees. We're headquartered in San Francisco. And I would just like to call out our C++ team. We have over 14 C++ developers that are focused on the XRP ledger. XRP is our digital asset, and I'll talk more about that in a minute. Our vision is to build that Internet of Value, which is a world in which money can move as easily as information moves. If any of you, I'm sure you've all visited a website or sent an email or in some sense moved information over the Internet. And I think the thing that you'll most notice is that it is absolutely seamless. It doesn't matter if you're using Wi-Fi, if you're using Ethernet, cable. The technology that you're using to access the Internet doesn't matter. And it doesn't matter where the website is or where the email is going. It works absolutely painlessly. And in the movement of money, it is the exact opposite. Anytime we're trying to transfer value, we have to be very, very concerned about where that value is going, what systems we're on, and what systems that value is going to. What we'd like to do is change that so that you can make a payment or move money as easily as information moves. So that means removing the friction from global payments, removing the cost, removing the complication, removing the latency, removing the uncertainty. Right now, we're in a world where payments are becoming more and more important. If I have a shop and you can see my goods, I want you to be able to buy them. You can see my goods, and we have good global shipping, we just don't have global payments. New companies like Amazon and Uber need a seamless global experience. They don't want to integrate with a new API or 3 different mobile payment companies in every country that they want to communicate with. They need fast payments. If you're Uber and someone needs milk, you want them to drive right then and there for you so that they can buy their milk. So that means that payment needs to be fast. And you need certainty. I've heard stories of international payments from small companies that have failed, and they just send the payment again because it's too difficult to investigate the payment, and they don't want to lose that relationship. You would never do that in the world of information. And of course, they need to bring costs down. If we're going to connect to the developing world, if we're going to connect to the unbanked, the payments can't cost $5 or $15. They have to be very, very small. And if we're going to enable completely new use cases, I'd like my phone to be able to buy Wi-Fi everywhere I go. I can't do that if a payment costs $5. It just would destroy any economy that we could get out of it. But today's payment networks are completely unsuitable to that task. They're walled gardens, they're slow, they have large numbers of failures, they're extremely expensive. They grew as a series, not as anything that was planned from the bottom up or the top down at all. It's just a sprawling mess. So what we're building is RippleNet, one frictionless experience to send money globally. And by that I mean a network of networks, just like the Internet. RippleNet participants tend to be companies, small banks, and payment providers, and the network that they're using tends to be built around banks and payment providers. And I want to stop on this slide for a second because I think I could give the whole talk about this slide because this is an Internet of Value. What do I mean by saying that it's an Internet? I mean it's not a single network. It's not like Bitcoin where we all have to agree on the exact same rules. Now you might say, well, we all have to agree on the same rules on the Internet, but we don't. You can use cable. You can use 3G or 4G. You can use Ethernet. Right? We've had a tremendous technological innovation on the internet where the means of access has completely changed, but the underlying protocols of TCP/IP, this sort of common language, has stayed the same. And you'll notice that this is a network of networks. So those boxes that you see here, these connectors, they connect different networks. They connect different ledgers. So for example, one of those connectors could connect Bitcoin to a bank, and it's ledger agnostic. So those blocks are analogous to routers. Just like routers move information from one network to another, those connectors move value from one network to another so that you don't have to find the path, you don't have to be on the same network. Ripple currently has a suite of 3 products: xCurrent, which is a real-time payment product primarily for financial institutions; xRapid, which is a way to move payments through a digital currency, XRP; and xVia, which is a way for payment originators to send global payments. xVia is kind of like the browser in the Internet of Value, I guess you'd say. It's like the client endpoint that lets you send payments. xCurrent is kind of like the router software. It's kind of like the Cisco of the Internet of Value. It does real-time settlement with bidirectional messaging. And you might think that this is just an obvious thing, like why would you send a payment without bidirectional messaging? Don't you need to know where it's going? Don't you need to know if the recipient exists? Don't you need to know how much it's going to cost? Well, believe it or not, in many current payment networks, you don't. You have no idea. This is a complete closed-loop payment system, so you know where the money's moving before the money starts moving. And it has atomic settlement, which means either all the money moves or none of the money moves. This is what means that you don't have to trust the connectors. So if I'm sending a payment and it's going through 3 or 4 connectors, if those connectors can steal my money, then I have to trust them. And then I have to be very careful in the connectors I select. But if they can't steal my money, if the payment is atomic, then I don't have to trust them, which means I can use the connectors that have the best service guarantees. Can you imagine if you had to trust the entire internet in order to access a website? It would certainly not be as useful as it is today. And now my slides don't want to advance. Oh, here we go. Maybe? Okay, so xCurrent is kind of that connector software in the Internet of Value. There are currently 100+ customers. They're pretty much exclusively banks. They're using this software today to route live payments in an internet-like way. xRapid is probably the most interesting product for this audience because it connects to a digital currency. It provides for the settlement of payments. Now, I want to just distinguish for a minute between payment and settlement, just in case that's not clear. When you use your Visa card at a merchant, you go to a restaurant and you pay with your Visa card, they consider you to have paid them. But what's really happened is you still have to pay your credit card bill, and the credit card company still has to pay the merchant. So what's happened is there's been sort of an adjustment of obligations, but there isn't an actual settlement. And part of the problem with payments today, part of the problems with the cost and the speed is the fact that we don't have this good way to integrate settlement with payment. And really, we couldn't do so. Like, until we had Bitcoin or similar systems, we couldn't move value at a high speed. XRP can move value in just a couple of seconds, so there's no reason not to settle right with the payment. And that's what xRapid does. It doesn't leave anything afterwards to be settled. It isn't like one bank has to later settle with another bank. The payment is actually settled with the payment. So that provides for access to liquidity when needed, which means you don't have to pre-fund. A lot of small and medium enterprises have to leave money all around the world so that they can access efficient domestic payments and systems instead of inefficient international payments. xRapid eliminates that requirement by allowing you to use liquidity to a digital asset that's already available. So how does that work? You do have to pre-fund in your native currency. So if you're a US company, you put US dollars at a US institution. You find liquidity between US dollars and XRP. You can then move that XRP in just a couple of seconds to an exchange, let's say in Mexico, and then either that exchange or some payment provider makes a Mexican domestic payment. So what you have is you have 2 domestic payments. You have a US dollar domestic payment from the sender to an exchange. You have a Mexican peso domestic payment from some sort of a liquidity provider or exchange to the recipient, and you have a movement of XRP. And what's happened is, in the real world, in production, in less than a minute, you've made a remittance through a digital asset. And the sender of the payment doesn't have to care about the digital asset, and the recipient doesn't have to care about the digital asset because the conversion is part of the payment process. So what is this digital asset? What is this XRP that's allowing you to do this settlement at the same time as the payment? Well, that's kind of been my primary focus. I joined Ripple in 2011 when Jed McCaleb, our original founder, had the idea of using a distributed agreement protocol instead of proof of work. That got us to a ledger that can get absolute finality in a transaction in approximately 5 seconds, can process over 1,000 transactions per second, and we think that it's the best digital asset. So why is that? Well, not all digital assets are the same. Digital assets compete in reach or network effects and their underlying parameters. Well, if we have an internet of value, if we can move across ledgers easily, reach is almost irrelevant. Like an internet service provider wouldn't tell you, we have all the websites you want. That would make no sense, right? They wouldn't say, oh, all of your friends can be emailed on Comcast. Like, that doesn't make any sense. Why? Because the internet has commoditized reach. Every internet service provider reaches the same websites, the same email addresses, the same everything. So what do they compete on? What does an internet service provider compete on? They compete on the price to you. They compete on the services that they give to you. Well, we still have that competition on reach with money. I don't know if you know Visa's slogan, it's everywhere you want to be. What does that mean? That's about reach, right? Digital assets commoditize reach. When we have these higher level protocols, you can use whatever ledger you want, and we can easily move across those ledgers. You're going to use the ledger that's best for your use case. So what is your use case? Maybe you like anonymous transactions, cloud storage, Internet of Things. There's as many use cases as there are digital assets. Well, almost. There's, what, 1,500 digital assets? And they all try to focus on their particular use case. Digital assets, to the extent that they're backed by cryptographic algorithms. That's what makes them secure. That's why we rely on them. You rely on Korean won because you know the Korean government has a policy that controls the rate at which it's released, and you have some confidence that it's going to continue to have value. What gives you the confidence that the system is going to continue to follow the same rules in a digital asset are those cryptographic algorithms that operate them. Bitcoin, the very first one, uses proof of work. Ethereum also uses proof of work, but now they're cutting over to proof of stake. Why? Because they've hit some of the limitations of proof of work, including things like the high cost and the slow block times. XRP never used proof of work. We built a distributed agreement protocol originally to solve that problem. Now, I want to back up just a little bit to explain clearly what it is, the problem that proof of work or proof of stake or consensus solves. Why can't we just all enforce the rules? Like, we all have the same software, we all know all the rules, we all can tell if a transaction's properly signed, we all have copies of the ledger. Why don't we just all verify every transaction? Well, we do. In Bitcoin, every node verifies every transaction. In Ethereum, every node verifies every transaction. XRP, every node verifies every transaction. So what is this mining doing? What is this proof of work, proof of stake doing? It solves only exactly one core problem that we can't solve any other way. And that's the problem where the network can make forward progress in two possible directions. If I have 1 Bitcoin, I have to be able to send it to Alice. If I have 1 Bitcoin, I have to be able to send it to Bob. But if I can do both, we have a huge problem. We don't have a useful system if I can produce thousands of valid transactions that all spend the very same underlying value. So what we need to solve is the double spend problem. That's what mining does. That's what proof of stake does. That's what consensus does. And how does it do it? It just puts transactions in order. If we all execute transactions in the same order, we can all agree that the first one is valid and the second one is invalid. It doesn't tell us which transactions are valid. It doesn't tell us what a transaction does, because we all know that. The thing that we don't know is an agreed order to execute the transactions. The net result of using a distributed agreement protocol instead of proof of work is that the ledger is much, much faster. Ordering transactions takes a lot less time than mining does. Mining takes a long time because it is by necessity computationally difficult. In addition, the fees are much, much lower because you're not paying millions of dollars a day to miners to order transactions. That seems a little bit exorbitant to me. Transaction throughput is much higher, well in excess of 1,000 transactions per second, and the cost of the system is negligible. 32 million ledgers have closed without issue since the system began operation in 2013. And consensus is more deterministic than proof of work. By that I mean that its behavior is more predictable. So for example, block times are completely unpredictable. They average 10 minutes in Bitcoin, they average 2 minutes in Ethereum, but you notice that they can be 30 minutes without a block, they can be 2 blocks found at the same time. It's what we call a Poisson process. It's essentially a statistically random behavior. Consensus is more deterministic. And what that also means is there isn't sort of a dictator that chooses which transactions go in which block. The network as a whole chooses which transactions go in which block in a fair way, which is important for some applications like if you're going to have a decentralized exchange, In Ethereum, the miner might order the transactions and might inject transactions to game the exchange for his benefit. And every 2 minutes, you have a sort of new dictator running your exchange. I don't think a stock exchange would operate well that way. Consensus doesn't have that problem because it's a consensus of the network on which transactions go where. There isn't one person who gets to game each block to his own personal benefit. The net result is that transactions are fully confirmed in about 3 seconds. The cost is very, very, very much less than a penny, and transaction volumes in excess of 1,000 transactions per second can take place on Ledger. We also have off-Ledger scaling through payment channels, so you can, if you interact with the same parties frequently, you can interact off-Ledger for a privacy and performance benefit. The net result is that compared to the other leading digital assets, we just have a much, much better user experience. If you think about it, other than competing on reach, and other than competing on features that don't affect use cases like payments, what is it that matters? Is it secure? Is it reliable? Are the payments fast? Are they cheap? XRP wins on all of those metrics. Again, over 35 million ledgers closed without incident since the system began, roughly 1 every 5 to 7 seconds. XRP is currently available on more than 60 exchanges. It's also the fastest asset for moving money between exchanges, again, because those transactions take only a couple of seconds. So what is this XRP ledger? What is the technology underneath XRP? Every digital asset has some sort of technology behind it, whether it's Bitcoin's blocks, whether it's Ethereum smart contracts. Well, obviously, there's sort of a cost of admission. There's a certain set of features that you just have to have, or you're not even in the conversation. So open source is a must. You can't tell people to rely on software and not let them see what the software does. That's an absolute cost of admission. Decentralization, again, there's nobody who has any authority to run the system any particular way. Ultimately, the users decide what the system does, and there's nobody who can tell them to do it differently. Ripple controls their own recommendations for how we think the system should evolve, but that's it. We have no special authority to make the system go any particular way. Reliability and security, I think, are extremely important, and I think you'll find that with our team of programmers, and we're focused on this use case that's just payments that doesn't have a lot of bells and whistles. It's not a very complicated use case, and that means we can focus on keeping the ledger secure, reliable, and its predictable behavior. We want the ledger to work the same way tomorrow as it did today, and if we're just adding lots and lots of features, that imposes costs on all users. At a minimum, they have to make sure the new feature doesn't create risk for them. So we don't want to sort of rapidly evolve the technology. I think maybe Bitcoin has taken that to an extreme, and maybe some other technologies have evolved too quickly. So what is that distributed agreement protocol? Well, again, transaction execution is deterministic. Every node executes every transaction. There's no way to tell another node what a transaction did. Just like in Bitcoin, you just give it the transaction and it follows the rules. We have this consensus algorithm that agrees on transactions to execute as a batch. Inside the batch, you just sort them numerically, not complicated. We also have a governance process, which I think is important. When we want to make changes in the rules, we have a way where we introduce new code, and then people have to upgrade to that code, or if they don't agree with the change, they don't upgrade to that code. There is no way to make your software do something that it is not coded to do. So if a new feature is proposed and you don't upgrade to that software that has that feature, you will never be affected by that feature. Now, you may fork off the network if the rest of the network adopts that feature and you don't. But ultimately, the control of what your node does is in your hands. You just have to make the decision of whether to follow the economic majority so that you can continue to exchange with them. Those proposals are voted on by the network, and if they attain a majority, it starts a 2-week timer. That gives people time to upgrade their software, time to investigate the security properties of that change, and time to argue against it if they don't like it. If you see an amendment gets a majority, you know that you have 2 weeks before it will be enabled on the network, and then you can start a campaign against it, or upgrade, or make your decision. But that mechanism ensures that 2 weeks later, if it holds a majority, that feature will be enabled on the entire network as a unit. And anybody who has opted not to enable that feature automatically forks off onto a subledger. And of course, they're warned about that. So how do our transactions work? We have programmed transactions. We're not as fixed function as Bitcoin. We're not as flexible as Ethereum. We're not a blockchain for programmable money that does whatever you want. We have transactions that perform specific fixed functions, and they operate on a view. I think this is something extremely important that we pioneered at Ripple, is this invariant checking. So what that means is if there's something that you definitely don't want to happen, like it would be really bad if a transaction created XRP. That would be the ultimate we don't want that to happen thing. So what happens is after we execute a transaction, the transaction executes on a scratch pad that shows what the transaction changed. And then we can look at that scratch pad and say, did this transaction create XRP? Did this transaction violate any rule? And if it did, we throw the scratch pad out, and we replace it with a scratch pad that says, this transaction did something really bad, and the network refused to apply its results. And that's in the public blockchain for everybody to see. Fortunately, we've never seen one of those. And why I think that's important is when you look at a public, I'm sorry. So why that's important is that when you look, let's say you ask me, can XRP be created? Is there some flaw in the code that would allow, that would be terrible. We definitely don't want XRP to be created. I would have to give you a bad answer. I would say, look at these 20,000 lines of code, and you'll see, nowhere in this code can XRP be created. But that's terrible, because there could be a bug anywhere in that code. There could be a problem in some small interaction that you might not see. It's a lot better for me to say, you want to know how you know that XRP can never be created? There's one line of code in the invariant checker that says, if this transaction created XRP, we throw it out. That kind of invariant checking would have prevented the attack that drained the DAO. Unfortunately, it wouldn't have protected the attack on parity. So it's not a solution to everything. But if you can identify the very worst things that you want to never happen and test for them, it can assure you that they will never happen. I think another key feature that we have is key rotation. If you're using Bitcoin and you want to change your key, you have to move all your money. You have to change your receiving address. We support key rotation with multiple signatures so that you can have multiple accounts that sign for your account, and they can rotate their own keys. That gives you a much higher level of security. Imagine if you're a charity receiving Bitcoins and you worry that your key might be compromised. Well, what do you have to do? You have to change your receiving address. You have to tell everybody the new receiving address. It's a mess. You may not have to move money. You don't have to do that on the XRP ledger. You can just change the signing key for an account. We have tags. In a lot of UTXO-based systems like Bitcoin, if you want to deal with hundreds of people, you need hundreds of separate receiving addresses that you have to watch. We have a much neater system where you attach a sort of tag to a transaction that tells you who to credit. We have fixed function transactors, but they have fairly powerful functions. We have an escrow transaction, which allows money to be held and claimed on a condition for secure payments. We have payment channels for high-volume, low-value transactions off the ledger. And we have checks that allow people to control how money is received. That's very important for entities where it creates a legal obligation if they get a payment and they don't know who paid them. And if they just want to return it, that creates a problem because they don't know who paid them, so they don't know who they're paying. A check gives the recipient control over the money they've received so that they can refuse it, for example. We have a decentralized exchange built into the ledger. We introduced it in 2012. It's the largest decentralized exchange, daily volume between $3 and $4 million, between 3 and 4 billion won. Who knew? I don't think many people know that we have a decentralized exchange. And because there's no proof of work, it's not gameable. Someone can't mine a block and control how that decentralized exchange executes. We have pathfinding so that you can pay across assets. You can hold Bitcoin on the XRP ledger. You can hold Ethereum on the XRP ledger. And you can pay across assets. So if I have Bitcoin and I want to pay someone XRP, the system will find the path for me. It'll draw off multiple order books to get the best exchange rate as it executes. So RippleNet is our vision for a sort of Internet of Value payment system with XRP as the settlement asset, so you don't have to move money around for days after the payment. And I want to close with just a sort of little bit of a perspective. So we had this blockchain technology that came out in the form of Bitcoin, and we looked at it and we saw what it did. And I think now that it's been some 8 years later, we can have a sort of introspective and we can say, what did Bitcoin let us do that we couldn't do before? How did it let us do that? What properties does it have? Are there other ways to get that property? What else can we do with this? We're in this sort of analysis phase, and we're just starting to move into the second phase where we say, okay, this does some things we couldn't do before. Let's use them to solve some existing problems in better ways. Ripple, as I said, laser focused on payment and settlement. Settlement is a huge pain point for companies and financial institutions around the world, multi-trillion-dollar business. But there are going to be this third phase where we find things that we couldn't even imagine doing, like what is the Twitter of blockchain? Who's going to be the Google of blockchain? When we start to use this technology to solve the problems that we didn't even realize we had, there's going to be an explosion of innovation in this area, and it's just a tremendously exciting space to be in. Thank you.